Welcome to this comprehensive tutorial on JavaScript's Async Await syntax, a cornerstone of modern asynchronous programming. As web developers, we often face the challenge of handling operations that take time, such as network requests or file reading, without halting the execution of our scripts. This is where asynchronous programming comes in, allowing us to manage such operations seamlessly. In this video, we'll dive deep into Async Await, exploring how it transforms asynchronous code into a cleaner and more readable format. Whether you're building web applications, working on server-side programming, or developing microservices, mastering Async Await is crucial for enhancing your development skills and creating robust, scalable applications. Let's get started. To understand Async Await, let's first consider the evolution of asynchronous programming in JavaScript. Initially, we relied on callbacks to handle asynchronous operations. While functional, this often led to callback hell, a situation where nested callbacks become cumbersome and difficult to manage. Promises emerged as a solution, offering a more structured approach by returning objects that represent future values. However, chaining promises still required meticulous management to ensure readability and error handling. Then came Async Await, introduced in ECMAScript 2017, which revolutionized the way we write asynchronous code. It builds on promises, offering syntactic sugar to make asynchronous code appear synchronous. Functions declared with the async keyword return a promise, and within these functions, the await keyword pauses execution until a promise resolves. This not only simplifies sequencing operations, but also enhances error handling through try-catch blocks. By understanding async await, you can write code that's both efficient and easy to maintain. Let's explore a practical example to see async await in action. We'll be using a React application to demonstrate how async await can manage API calls efficiently. In our setup, we have a simple app that fetches user data from an API and displays it. The async await syntax is used in the getData function within the useEffect hook to fetch data asynchronously, handle potential errors, and update the component state accordingly. This example highlights how async await improves code readability and maintainability, making it easier to handle complex asynchronous operations. In this demonstration, we'll see the React application in action. Upon launching the app, the interface initially displays a loading message while it fetches data from a mock API. Once the data is successfully retrieved, the loading indicator disappears, and the user list is rendered on the screen. This seamless transition is made possible by the async.await syntax, which handles the asynchronous fetch operation efficiently. If any errors occur during the fetch process, they're captured and displayed to the user, ensuring robust error handling. This demo showcases how Async Await can enhance user experience by maintaining a responsive interface while managing asynchronous operations effectively. In conclusion, the Async Await syntax is a powerful tool in the JavaScript developer's toolkit, offering a streamlined approach to handling asynchronous operations. By transforming complex asynchronous code into a more readable and manageable form, it empowers developers to build efficient and scalable applications. As web applications grow in complexity and the demand for responsive user experiences increases, mastering Async Await becomes not just beneficial, but essential. We encourage you to integrate Async Await into your projects and explore its potential further. Thank you for joining this tutorial, and happy coding.